It's Math 3A, section 3.6. But before we do this, let me recall some of the derivatives formulas, such as y equals x to the m, then y prime is mx to the m minus 1. That's the power rule. And then we had the chain rule, y equals u to the m. U can be any function, so it's m u to the m minus 1 times the derivative of u. The next thing is, if you have what we call the product rule, u times v, y prime, it's u prime v plus u v prime. Also u over v, that's the quotient rule. Y prime is u prime v minus u v prime over v squared. This is product rule. This is quotient rule. Both of them from section 3.2. And we have the power rule came from 3.1. So this is power rule. And this is the chain rule, very important, chain rule. So we need to know all of this stuff. And the other thing we recall, some properties of logarithms. We need to recall them. So after this, we recall the properties. Natural log of x times y, or log x times y, is natural log of x plus natural log of y. And natural log of x over y is natural log of x minus natural log of y. And natural log of x to the m. All this came from algebra, and we reviewed them the first 2 weeks of classes. Log of a base b is, you can change your base formula, log ln of a over ln of b. Also, if y equals natural log of f of x, for now, this is what we need to learn this section. What's the derivative of this? Okay, what's the derivative gonna be? So the derivative is f prime of x over f of x, no more ln. So you always take the derivative of the function inside divided by the function itself, no more ln. So find y prime to practice on this. If y equals natural log of 5x, or y equals natural log of cosine 7x. What y prime would be here? Try it. So here we do the derivative of this over itself. So derivative of 5x is 5 over itself. Notice these cancel, so the answer is 1 over x. We do the same thing here, derivative of this, so cosine 7x derivative over itself. Derivative of cosine 7x is the derivative of 7x, which is 7, and derivative of cosine is negative sign over itself. You can notice sine over cosine is tangent, so you can write as negative 7 tangent 7x. Next one, we use the product rule. So the product rule says you take the derivative of the first one times the second plus the first one times the derivative of the second. So what's the derivative of x cubed? Is 3x squared. Natural log of x plus x cubed. Derivative of natural log of x is the derivative of x over itself. So y prime would be 3x squared natural log of x plus x squared. Plus x squared. Just to recall, you know, if we have y equals sine u, y equals cosine u, you're gonna find, recall the formulas for these if you haven't watched the videos yet. Derivative of sine u is u prime cosine u. Derivative of cosine u is negative u prime sine u. Derivative of tangent u is u prime secant square of u. The more you practice on this, the better for you. We're going to do also cotangent u. We're going to find secant and cosecant. This is negative u prime cosecant square u. This is u prime secant u tan u. And the last one is negative u prime cosecant u cotan u. Sometimes people confuse about the negative. Where's the negative going to go? If the function starts with c, there should be a negative sign. If it starts with c, there should be a negative sign. Sometimes they ask you to find the derivative of a more complicated log function like this one. So what are you going to do with this one? So one thing about this, don't find the derivative right away, because if you find derivative right away, it's going to be a lot more complicated. So what do we do in this case? First thing, before I do y prime, I'm going to rewrite using the properties of natural log. If natural log the top, natural log the bottom one. Okay. Nothing I can do for the first one. I can't split it up. But the second one, I can rewrite the square root as 1/2. So x plus 3 to the 1/2. I'm still doing algebra, okay? So let's keep this the same. Bring the 1/2 down. Natural log of x plus 3. Nothing I can simplify more. Then y prime is the derivative of this, which is 2x over itself. Minus 1/2 stays the same. Derivative of this is 1 over itself. And you can leave it like that, that's fine. So all of this is just algebra. One step from here to here is the calculus. Now, how about if y equals log f of x base b, what would be the derivative? Right? So I can prove to you what the derivative of this is. First thing, let's use a change of base formula. Natural log of the top, natural log of the bottom. And this can be rewritten as 1 over natural log of b, which is the constant, times natural log of f of x. Then, from here, if I want to find y prime, we keep the constant out. The derivative of this is f prime of x over itself. So what is find y prime if y equals log So the formula says 1 over natural log of the base times the derivative of this, which is 2x over itself. That's it. You can leave it like this. Another one I want you to try. Find y prime if y equals log base 3 of x cubed minus x. Try this one. So now y prime would be 1 over natural log of the base times the derivative of this, which is 3x squared minus 1 over itself. So sometimes they ask you to find the derivative, but you don't see any log functions involved. So they say find y prime if y equals, say, x squared root of x plus 2 over, say, x plus 1 cubed. If you try to use quotient rule here, it's going to take a lot of time. So what we can do, we can use logs or natural logs to first rewrite this. So do natural log both sides. And what I'm doing is called in mathematics logarithmic differentiation. So I'm using logs to differentiate complicated functions. Keep the left-hand side the same. You can do natural log of the top. All I'm doing algebra now, minus natural log of the bottom one. Then keep this the same. This is natural log of the first one plus natural log of the second one, minus natural log of this. So natural log of y equals, you can bring the 2 down. This one is 1/2, you can bring it down. So this way there's no log in there or natural. Minus, you bring the 3 down. Now I can simplify further. So now what do? Now we differentiate both sides. Differentiate both sides means we find the derivative of this one for both sides. So this one is derivative of natural log of y is y prime over itself equals 2 times derivative of x is 1 over itself plus, keep the 1/2. Derivative of x plus 2 is 1 over itself minus 3 outside. Derivative of x plus 1 is 1 over itself. Then multiply both sides by y. So y prime is y times 2 over x plus 1 over 2 times x plus 2 minus 3 over x plus 1. But remember what was y? Y was given to us as x squared root of x plus 2 over x plus 1 square cube, and keep everything else the same inside the bracket. You don't have to simplify more, you can just leave it like that. Again, this is called logarithmic differentiation. This is called logarithmic differentiation. You may try this one. Find y prime if y equals x raised to x squared using logarithmic differentiation. Move on. So here again, we don't have a formula for, we have a formula if you have a number, to some function, or if you have a function to some number, but we don't have a formula, a function to a function. So what do we need to do here? We take ln both sides, keep the left hand side the same, bring the x squared down by the properties of natural logs, then differentiate both sides. What's the derivative of natural log of y? It's y prime over itself equals, what's the derivative of x squared? Is 2x by the product rule times the second function plus, keep x squared, the derivative of this is 1 over x. Then you can multiply both sides by y. This stays the same. This simplifies to x. But remember to replace the y with x to the x squared. Keep this the same, plus x. Keep in mind at all times the 2 point something is defined as the limit as n goes to infinity of 1 plus 1 over n to the nth power. You probably need it at some point. Another example, try y equals 2x minus 1 all to the x power. Find y prime. Go over it. So natural log both sides. Natural log of y, bring the x down. Natural log of 2x minus 1. Then differentiate both sides. Y prime over y equals. Now we use product rule. Derivative of the first one times the second one plus the first one times the derivative of the second one. Multiply both sides by y, and let's see what we get inside the bracket. Derivative of x is 1, so you get natural log of 2x minus 1 plus x. Derivative of this is 2 over itself. But y is 2x minus 1 to the x power. Keep this the same. Plus 2x over 2x minus 1. That's what this section is about, is how you find derivatives of logarithmic functions. But as you notice, we use product rule, we use chain rule, very important from the previous sections. And we use implicit differentiation from 3.5 as well. So very important, you go back and redo all the problems from the previous, or watch the videos from the previous sections.